Thank you all for taking the time to attend this event today. In this presentation, I'll be speaking on behalf of my team at Freedom Photonics regarding our NAVAIR program targeting the development of a multi-core fiber optic packaged photonic integrated circuit, specifically a multi-core fiber receiver module. I'll start by introducing Freedom Photonics as a company, and then I'll get into the challenge that this receiver addresses and summarize our progress to date, as well as the next steps that we anticipate in commercializing this product. To start off, a little on Freedom Photonics. We are a US-based manufacturer of photonic components, modules, and subsystems with a focus on unique, high-performance photonic solutions. We're a growing company of about 50 employees, primarily engineers, and our capabilities cover design, fabrication, packaging, and testing of our components and subsystems. We address fiber optic communications markets as well as sensing and illumination. Our key products include tunable lasers, high-power single-mode lasers, and high-power photodiode receivers. The Navy challenge, which this program addresses, is well known. As RF sensor and instrumentation requirements increase in complexity on avionic and naval platforms, the amount of RF cabling increases in turn. Conventional RF coax is lossy, heavy, and susceptible to EM interference. RF photonic links address many of these issues, reducing the size, cost, weight, and power of these RF systems by replacing coax with lightweight fiber as the transmission medium for these signals. However, the challenge of these systems is in carefully designing both the transmitter and receiver components, which transduce between the optical and electrical domains. The multi-core fiber receiver I will highlight in this talk is a type of balanced photodetector, which is a specialized receiver component consisting of two anti-parallel photodiodes. A balanced photodiode architecture enables the suppression of common noise on the two devices, resulting in a receiver with shot noise limited performance, significantly improving link gain, spurious-free dynamic range, and noise figure. High-performance photonic links and avionics sensor and communication networks require high-performance photonic components which can withstand a mil-aero environment. As I mentioned on the last slide, a balanced receiver is a critical component for overcoming current limitations of a photonic link. We have successfully developed such a receiver on a related NAVAIR program, where we developed a ruggedized balanced receiver with a dual fiber input. However, to take the performance of this receiver a step further, we are moving to a multi-core fiber input, in which a single fiber carries, as the name implies, multiple cores, rather than having two separate optical fibers. A known issue with the dual fiber input is a low tolerance for differences in the two fiber lengths, a tolerance which decreases as you move to higher speed signals. Multi-core fiber offers a solution to this issue by coupling both the physical and virtual path lengths of the two cores. Naturally, the first requirement of this receiver is accommodating a multi-core fiber input and balanced detector architecture. Additionally, to enable links with low noise and high spurious-free dynamic range, it's necessary to design detectors which can handle high optical power signals without saturating. In other words, these receivers need to maintain a linear relationship between input optical power and output RF power, a metric we refer to as linearity. Next, the detector needs to operate at a high bandwidth, in this case, 40 GHz. It also needs to work efficiently to convert the input optical signal into an electrical one, so it needs to have a high responsivity. Last, because this receiver is intended for harsh mil-aero environments, it must be secured in a ruggedized package which can accommodate a wide operational temperature range. In a separate, synergistic Navy program, we designed, fabricated, and packaged a dual-fiber balanced receiver module. This module enables high-performance photonic links with low noise and high spurious-free dynamic range. And for the first generation of devices, with the dual-fiber input, we achieved a 3 dB bandwidth of 20 GHz and a common mode rejection ratio of 20 dB. The responsivity of those devices was about 0.7 amps per watt. The key next steps for this technology are moving to better performance and accommodating the multi-core fiber input. Since the beginning of the Phase 2 program, We have redesigned our epitaxial stack and detector geometry to achieve higher bandwidths and RF output power targets while maintaining a high responsivity. We have also done a significant amount of fabrication processing development in changing the device geometry to accommodate the narrower pitch of the multi-core fiber. There have been some COVID-related fabrication delays on these parts, which has changed the timeline shown somewhat, but the fabrication lot for these new devices is finishing up within 2 months. In parallel, we have redesigned the carriers for these devices to improve their response at higher bandwidths. Once the fabricated devices are packaged and characterized, we anticipate this technology will be at about a TRL 4. If the option on this program is exercised, we anticipate the pilot production run for these devices will finish in late 2022. To achieve a TRL 8 and complete the development effort, we anticipate we will require additional funding through a second Phase 2 or a Phase 2.5. This high-performance receiver product is an enabling technology for low-noise RF photonic links in next-generation avionic platforms. Critically, high-linearity detectors which operate at high optical powers have significant benefits within an RF photonic link. Operating these receivers at high photocurrents results in lower link noise and a higher spurious-free dynamic range for the link. Further, as I mentioned before, the balanced configuration suppresses common noise, enabling higher system performance, which is compounded through the use of multi-core fiber, which minimizes path length differences, both in physical length and virtual length, as the strain on the two cores is equivalent. Finally, the ruggedized package for these receivers is compatible with the mil-aero environment, enabling wide platform deployment. This high-performance receiver is a key component in a number of military systems, appropriate for a wide range of RF photonic systems and RF photonic signal processing applications. The target Department of Defense applications for this product are microwave photonic links for radar, antenna remoting and sensing, and electronic warfare. Expanding to potential commercial markets, we see applications for these receivers in commercial RF photonic systems, such as 5G wireless, as well as fiber optic telecommunications and data communications networks, as well as high-speed communications within non-military vehicles. Freedom Photonics is currently seeking partners on this technology. We're hoping to partner with a prime contractor or a system integrator active in avionic environments or other harsh environment networking applications. Such a partnership would enable the integration of these receivers into government platforms and programs of record. The expected role of Freedom within this partnership would be as a module supplier, as we are vertically integrated in design, fabrication, and packaging of such modules. We are also open to the possibility of licensing our technology to a commercial partner. We've had some success in the past transferring in-house technologies on similar efforts, and we see a major opportunity with these balanced multi-core fiber receivers. Thanks very much for your attention today. If you're interested in hearing more about our multi-core fiber balanced receiver product development, please don't hesitate to contact me at my email address listed here. If you have general inquiries about the high-performance photonic component products and technologies at Freedom Photonics, or if you're interested in a custom photonic design, I would invite you to check out our website, virtual booth, or reach out at info@freedomphotonics.com. Again, thank you for your time and have a great day.